Okay, perfect. Hey guys, good evening. This is Abhishek Anami. Can you guys hear me? Can you just send me like a thumbs up or maybe leave a comment somewhere? Hey guys, if you can hear me, can you just leave a comment there that you can hear me because I'm having some issues here. Hey guys, good evening. Jyoti just confirmed that she can hear me. That's a good news. Good evening, this is Abhishek Anami. I've just completed audio engineering and music production course at a music school based in Sydney called as JMC Academy. Today we'll be just talking about, I think we'll be scratching the surface of audio engineering and how theater audio are correlated. How they can be. So today we'll be discussing, of course, what is audio engineering, how is it helpful in the current world, how can an audio engineer help in the world of theater, audio engineering and architecture, types of microphones, microphone capabilities, mixing of the sound, production and mastering. You might be wondering how do these topics like relate with the group that we are in that's related to theater itself. When you go into a theater to perform, these are the things that actually happen in the background. Where you're just given a mic which is just clipped onto your clothing, and then you do not really worry about what actually happens in the background and how that mic actually picks up your sound. Are the all things that I'll be covering in today's topics. Uh, Going on to the next slide. It's the title of the talk. What is audio engineering? Uh, In simple words, it's just getting sound from one place to the another. Because while I was a small kid and watching movies, always wondered like how can someone capture an actor walking with the boots and you can hear those boot sounds. You can hear the raindrops and you can also even hear the thunder that's actually happening live in the movie. I always wondered like how it was possible. And when I learned to the course, I just found out that it's all because of the audio engineers who actually work when the movies are shot in the background. When the movies are shot, it actually comes to the studios, and those sounds are actually reproduced in the studio, and then they are added to the movie, and then they're released into the real world. So you might also wonder, like in just simple words, audio engineer would be someone responsible to capture an original piece of music from a source. It could be any source where the sound is coming from, and convert it to electrical energy. And then from there, the audio engineer can actually manipulate those electrical signals. And then we can divert it to any direction that we want. It can either go to the speakers, it can either be stored, it can be either playbacked, or you can even share the sound, right? Going to the next topic, how is it helpful in the current world? Audio engineering is fairly kind of a newer subject, even in the music industry itself. There are like a wide range of roles. Once you finish your engineering course, you can actually get into. One is the one that I've studied. That's audio engineering and music production. That actually deals with recording in studios. Whenever you hear a song, those are actually recorded in studios, and audio engineers who complete the course get to go into the recording studios. And the next one is live sound. Whenever you guys go into live shows from your favorite artist, there are actually a bunch of audio engineers working in the background, who actually make the show happen. Even in the theaters, when you guys go on the stage to perform, like I said, you can just someone just comes in and hands you the mic, and it just clipped onto your clothing, and the entire show you actually forget about it. There's actually a guy in the back end who is always controlling those signals and then manipulating them and then making it just sound good. Um, the next one is corporate audio tech. That's fairly a newer field now. Whenever these bigger corporate companies hold the big seminars, we also have like audio engineers just dealing with that stuff. And the next one is environmental sound design. It could be just adding a characteristic to existing space. For example, when you walk into a restaurant for a romantic dinner, you can hear a very nice, fine song playing in the back end. It just enhances the overall ambience of the place. Or, for example, when you go into a hotel lobby, you can also hear some sounds. It's just dealing with designing those stuff there. Audio forensic, it's working for the law enforcement. For example, when if someone has blackmailed you, trying to pick up those minor details in those calls, or if a TV channel is running a sting operation, placing the mics with the actors, recording, capturing all those stuff. Or, for example, God forbid, if there is a plane accident somewhere, we have something called as black box. It usually records each and every conversation that the pilot and the co-pilot have between them. Uh, Audio engineers, whenever the black box is found, that's a very key important evidence why the crash actually happened. It's usually given to the audio engineers. They just extract the sound from it, they manipulate it, they add some EQs and stuff, they make it sound good, and then it's given to the investigating officers. And the next one is acoustic and design. We'll be discussing this one today. That's how architectural acoustics and audio engineering come hand in hand. The next one is cell phone ringtones and applications. When you pass out audio engineering, you can even get into software side of it, where actually finding that key ringtone that stands out from your other competitors is actually very important for the software companies. So they usually deal with that stuff. Car audio, it could be fairly simple. You can listen to it every single day. Even the audio engineers like design where those speakers should go and how they should sound. Commercial TV, you can always see video and audio going through parallelly in the sync in commercial TV. That also actually happens because there is an audio engineer sitting in the studio, or else imagine if the video is showing something else and the audio is showing something else, it doesn't really match up. So the audio engineers also help in commercial TV world. And post production is nothing but like I was talking about. The footsteps of an actor, or it could be rain and thunder, or the other visual sound effects that you can hear in the music or in the movies. There is no way you can capture it live when the action is happening in the sets, because it will also have all sorts of disturbances to it, right? So post production is a very big industry where you can actually go in after finishing your audio engineering and so moving on. We'll start with audio engineering and theater. Many people might have wondered like how these two things are related. Um, Architecture, acoustic treatment is a part of audio engineering. When the architects draw out a plan of the building, acoustic engineers are consulted alongside to treat the building with acoustic materials in order to minimize. When you build a empty hall, there you can usually hear echo, a bit of reverb, all those elements. Uh, so acoustic engineers are consulted when the designs are being made. Uh, so they can also plan like how we can treat the space once it's ready, and we can reduce these elements called reverb, echo, and all that stuff. Because just imagine how awkward it would be if you're in your place and if you say your name once and you can hear it like 7 times. Every place need not be Gulgumas, right? So it plays a very vital role, even in when you're designing hotels and stuff. We want to keep the privacy of one room, so you don't want whatever two people are having conversation in one room to be heard by the other person in the another room. So acoustic treatment also comes in handy there. And of course, when you're building big professional theaters and movie theaters, audio engineers are consulted when they are building them, and then they help in. So audio engineers play a key role in designing any spaces, specifically professional theaters, cinema halls, or the main example would be, the best example would be designing the railway platforms, where, for example, if you're standing on platform number 10, it would be very weird if you can hear the announcements that are happening in platform number 1. So we create those separations between the platforms using acoustic engineering or per se audio engineering as well. So next one, I'm talking about this architecture and acoustics and all that stuff. For example, let's consider there's a blank room, this empty room, which does not have anything in it. How can we actually treat that particular room with the acoustics engineering, right? Uh, Sound is not something physical. You cannot like just grab it and keep it in your pocket, right? Uh, so there's only little we can do about it. So a sound can either be absorbed like completely, or it can be reflected from the surfaces, or it can be diffused, like it can be spread across the space. These are the only three things that you can do with the sound. And that's where the acoustic engineers or audio engineers come in. So I'll also walk you through how to treat your room. For example, if you guys go in for a theater performance sometime when this whole pandemic completes, you can have this information handy and you can just enhance the performance of the space by just following these simple rules I can show you today. So whenever you go into a empty venue. Just do these few things that I'm going to show you next, and it will just overall increase the ambience and the experience that someone can have in that space when they come to watch you next time. So when you're treating a room, one of the first important part of it is finding the first reflection point of the room. That's nothing but, for example, if you consider this example, uh, there are two speakers here. The sound is coming out of from them, exam. So when they're coming out from there, the first reflection point would be at what point of this wall it hits the first. So that'll be the first reflection point. To find out that, you need to find the center point of the room. So once you have found the center point, that's where I've placed this small couch there. You ask one of your friend to just sit down there, and if you, or maybe you can ask your friend to stand at the center point. Ask your other friend to grab a mirror and then slide it against either side of the wall. Let's say left side of the wall for now. And then if it just starts moving to the speaker, there will be a point where the person who is sitting or standing here can see the speakers in the mirror. So that will be your first reflection point. And those points are ideally a very key important point for in order when you're considering acoustics and reflections. So treating those points is very important. So what you do to treat those spaces would be like you see in the picture. I have these small panels. These are nothing but made up of acoustic materials. Like I was talking about, the sound can either be absorbed or it can be reflected, it can be diffused, or it can be, yeah. So there's only three things. Just give me one moment. Yeah, like we know, we can only do three things with the sound. So some people might say, with the first reflection points that we have just found, it's easier if we hang in the absorptional panel there. However, that's not actually true. Instead of the absorption panels, if you have these medium curved diffusers there at your first reflection points, that's more ideally suited because when you have invested so much money in buying good equipment like the speakers or could be microphones, you don't want your first emitted waves to be absorbed right here. You want them to diffuse through the space and enhance the experience. Excuse me. Enhance the experience of the listeners, right? So we usually place diffusers and reflectors here so that the sound wave, when it hits here, it gets diffused and then it gets reflected throughout the space. And then we can even place similar, you can even give similar treatment on the ceiling as well. You can just consider the same point there and then place two of the diffusers there because sound is a 3D. So we have to treat it in all the dimensions that we can. And especially in the corners, these are the worst parts of the room in any room considered. So these needs to be treated with the absorption panels. Um, and then once you come to the rear end of the room, they need to be treated with the absorptional panels as well. So if you go into your next venue where you're performing your play, just find the center point of the room. And then even if you cannot find the absorptional panels, the professional ones, you can even use small rugs, like just layer them like 3 to 4 times and then just hang on there. Like these two are the critical points, just hang them there. And then at the end, even at the back of the room, just hang few of them through the entire space. It should usually enhances the experience and just you can see the difference when you just do those simple things. If you can do the ceiling one, that's amazing too. I'll just show you an example of a theater that we had designed when I was studying in music school. So here, if you look at that, it was just a corporate event that was happening here. If you look at the sound, this is a stage. We have reflectors here, and we have reflectors on the wall as well. It was inbuilt the time the theater was built. And then on the top of the ceiling, we have reflectors and diffusers as well. So here, if you treat them with the rugs, and then on the top, if you can add some rugs as well, and at the back end, if you can have like multiple layered rugs, which can usually absorb the residual of sound and make way for the new waves that are coming in from the source. That will really enhance the experience of your playing for both you and your audience as well. So the next one is types of microphones. This becomes very important for any player needs to choose the optimum right mic for the performance and right mic for an individual as well. So I'll just tell you about the polar patterns of the microphones. There are several microphones in the industry. Few of them have different polar patterns. So the different types are cardioid, super hyper cardioid, omnidirectional, figure eight microphone, shotgun microphone, and switchable and multi-pattern microphone. When we talk about cardioid microphones, the image shows itself and explains itself as well. Whenever you're pointing it towards a source, only this part of the microphone is highly efficient and picks up the sound waves that are coming in, and everything else behind here will be rejected and they won't be picked up by the microphone. This is like mostly used in the stage plays and the theaters as well, if the production budget stays there. So these are like mostly used microphones for a theater performance because it eliminates all the unwanted ambience noise and it concentrates only towards the performer. The next one is a super and hypercardioid. It's nothing but cardioid microphone itself. However, the range to which you can direct it towards a source just reduces slightly, and it's like it directly pointed to one single person rather than if you go to cardioid, it's much bigger than the hypercardioid. And the next one is omnidirectional microphones. We have something called as clip microphones nowadays, which are like very thin. Most of those microphones are omnidirectional, and for example, if it's a big play of more than 25 to 30 people, we did one in Sydney while I was studying. I was more than 25 people, and we had to give each one of them a clip mic, and uh, those were usually omnidirectional microphones that we use because we usually clip them on to a performer somewhere near his face. I will show you one clip moving forward. It actually shows you how we actually put a clip microphone on a performer, which is omnidirectional, which picks up everything that's happening around the performer's face. If that's omnidirectional, like you say, it picks up from the sound source from every single direction. And the next one is figure eight. Like it says, it can only pick up this sound source from this and this part, and it completely rejects and eliminates whatever sound noises that are coming in from here and there. Shotgun microphones are highly used for movie shootings, nothing but when you want to focus just on performance dialogue. We just hang it on from the top. It's usually not seen in the scene itself. It's usually just above the performer's head, and it directly focuses on the performer's dialogue, and it does not pick up anything else. The next one is switchable and multi-pattern microphones. We don't really use this type of microphones in theater because these are like pretty expensive and things can go rough sometimes on when the performers are performing. So we don't usually use them unless and until they come to the studio for the next one is just the types of microphones. There are only two main ones. Ribbon is like only used in recording studios, but for performances of what I have seen, most of the production companies use dynamic microphones and condenser microphones. Dynamic microphones is nothing but a transducer which just converts signal into electrical signals. It just consists of a diaphragm, like you see in the screen. It consists of a small coil and then the magnet. So every time a sound source hits the diaphragm, it vibrates, and then this coil is actually connected to the diaphragm, and that one vibrates too. And that vibrates through the magnet here that you can actually see that's placed within the coil. Like like when a coil like moves back and forth in the magnetic field, it's converted into audio signal, electrical signals here, and then that's how a dynamic microphone works. And when it comes to condenser microphones, it's similar thing, but we do not have a magnet and a coil here. So whenever a sound waves hits it, this is electrically charged plate that you can see in the back end, and this is the diaphragm. Whenever this vibrates, the electrical signals change in between this space, and this one is, like I said, electrically charged. We have phantom power from that plate, that's plus 48 volts. And whenever there is an electrical signal changes here, it's then converted into audio signal, and that's how it's made. The reason why I talk to you about how a microphone works is it's very important as a performer to choose the right one when you're working, right? So most of the performers do choose condenser microphones because it helps them to capture the high frequencies and the low frequencies, and it just gives it a better effect. But when you compare it with the dynamic microphone, the energy that's needed to vibrate the diaphragm in the coil, it's significant when you compare it to the condenser microphone. So most of the performers do choose condenser microphones, and which are omnidirectional as well. And we'll also talk you through about how to set the stage when you're actually performing. It's actually done by audio engineers, but it's also useful if you can have this knowledge within yourself. For example, if you do not have lavalier microphones, that's nothing but the clip mics that we have. Those are pretty expensive, and for example, if you have a play of around 25 to 30 people involved in a play, most of the production companies do not opt for renting or buying 25 lavalier microphones. So they usually choose for some of the dynamic mics as well in the low production companies. So if you're using lavalier microphones and the production budget allows for it, then that's amazing. You can just give one each for the performer, and then that's going to sound amazing for you guys. But if the budget and the production does not allow for it, I would go with the dynamic mics itself. You can see those dynamic mics everywhere. So you just need to follow 3:1 rule. You can see a small image that I've prepared here. If this is the performer, the microphone should be kept 1 feet away from his mouth, and then the next microphone that you're going to place on the stage should be 3 feet away from the next performer. And so you can place like few microphones on the stage at the start of the stage, and it's not going to sound great, but it's going to help you get through it. So those are like the two famous setups that we use when you're miking a theater. And the next one is mixing and mastering. When I was talking about like a big Broadway shows where there are like 25 performers performing a play, each one of them will have a lavalier microphone, that's a small clip-on microphone, which is hidden inside the actor. Just imagine there'll be like 25 individual channels on the mixer. That's me sitting there, mixing one of these songs in my studio. But each one of those strips that you see, that's one channel. So if you have 25 performers, that's going to be 25 channels. And at a given point, there could be one or more performers speaking at once. Or, for example, when you're mixing up a song, there will be 25 to 30 elements that will be coming up at the same time. Mixing is nothing but balancing those frequencies, balancing those individual instruments in a song and in a performance. Uh, that's what a mixing engineer does. It usually takes once everything is recorded in the live theater play or in a movie scene or in a movie song. Mixing engineer actually spends hours and hours sitting in the studios just finding the right balance of all the instruments or of all the people that are involved in the play or in a song, uh, and make it like a nice, beautiful song. And once the song is mixed, it's then again taken to a mastering engineer who is again a different person. The main job of mastering engineer would be if you're launching your show into Netflix, they will have different configurations. If you're launching it to YouTube, they will have different audio specifications. Or if you're trying to broadcast it over radio, they will have different audio specifications. It's just preparing whatever that we have recorded in the live show over in as a song uh, to be mastered and then converted into those specific formats, and then we can share it with the those specific channels that we just discussed. And that's all from me. I know it was very brief, but it usually takes a lot of time to dig into each and every single aspect. I just wanted to show you guys, like, okay, sorry, I was just reading out the comments. Sure. So I know there was like the topics that we discussed are very brief and just scratching the surface, like I said in the beginning. But it just gives you an idea of what actually happens in the background. And the next time when you're given a mic, uh, like you actually know what that is. You can just ask the audio engineer, is it a condenser microphone or is it a dynamic microphone? Or you can just go into the mixer that I showed you here. Like every performance will have mixing engineer sitting here with a console like this. It might not be this big, but it could be a smaller one. But just try to spend some time with them and actually get to know what actually happens when you speak into the microphone, and what he actually does there, like EQing them, balancing them. Um, yeah, and the next time when you go into a venue to perform something, you can also know if it's not sounding great. You can also know like how we can, with just minimal budget, how we can make it sound a little bit better the next time we go to perform something. So that would be from me. Let me know if you have any questions. Okay, I guess there are no questions. Have a good evening, guys. Thank you very much for this opportunity.